Yeah. Minus Q into Q by
So as per the question, one end of a spring of negligible unstretched length and spring constant K is fixed at the origin 0, 0 and a point particle of mass small m carrying a positive charge small q attached at its other end. This is a small charge point q. This is one small dipole of moment p. The entire system kept on a smooth horizontal surface. Term is very important. Smooth horizontal surface means no loss of energy. When a point dipole p vector pointing towards the charge small q fixed at origin, this is the origin. The spring gets stretched to a length small l. And when the dipole is like this, at point q, it will produce the electric field in which direction? Away only, na? Electric field away and force also away. That's what L is the stretched length, not original length. L naught may be original length. L is the stretched length after elongation. Am I clear, all of you? But still they are in the equilibrium only, na? Still they are in the equilibrium in the sense. What is the Himalayan, are you there? Huh? Once you switch off your phone and restart and join once again. So both the dipole and the point Q, which are in the same state of rest only. For suppose if you take the point Q, how many forces are acting? Repulsive electrostatic force by the dipole and the pulling force by the tension. I mean the spring. X equal to elongation. Are you understanding? Huh? Now new length equal to L naught plus X. Now I can write the spring force equal to electric force. What is spring force formula? K into X equal to what is the electric force due to dipole on the charge? Q into electric field due to dipole. What electric field due to dipole formula? This charge is on the axial line only, na? Please
A
say
cube
yes
by R
or
cube.
what is the electric field due to that formula?
A cube by R cube.
2 into K into P divided by how much? R cube. R cube here distance between the dipole and the point means L cube. Here you should be little careful. This K is different, this K is different. So 2kp, sorry, 2pq by L cube. K value how much here? 1 by 4 pi epsilon naught. Kx equal to how much here? Tell me. 2 ones are 2, 2s are. Pq divided by 2L cube pi into epsilon naught. Keep aside, this is the equation number 1. Definitely in the future it is very useful for us. Okay, now uh, they set the oscillations in the which is we have to read once again. If the point mass is now displaced slightly, delta L, from its equilibrium position and release, which is found the frequency. Earlier, we'll redraw freshly. This is the dipole. Here, this is the charge. The length is small l between them. The spring is elongated. Delta L. Tell me how many forces are acting? One is spring force. Spring force how much? K into already x meter elongation is there. Next delta L also elongation is there. Say yes or no. And repulsion force also there. What repulsion force? Q into electric field. Means the net force I can write spring force minus Q into E. Net force formula. According to Newton's second law, what is net force formula? Mass into acceleration. What is spring force? K into x plus delta L minus Q into what is electric field due to this dipole on this point Q? Same 2k P divided by distance whole power Q. Mean distance is how much? Now new distance how much? Tell me. L plus delta L whole power 3. So M into A equal to K into X plus K into delta L. The 2kp should be very careful. 2q P and 1 by 4 pi epsilon naught and 1 by L plus delta L whole power 3. My target I have to convert in this term A equal to minus omega square into X. So I can find the angular frequency or time period. So right side I have to remove all these terms like delta L, these terms, big terms I have to eliminate. I have to continue only X. So that is my strategy. So I will do that. MA equal to K into X plus K into delta L minus 2QP by 4 pi epsilon naught. 1 by L I can take common. So 1 plus delta L by L and whole power 3. So MA equal to Kx plus K into delta L minus 2QP by 4 pi epsilon naught and into 1 by L cube and 1 by this 1 plus delta L by L whole power minus 3. This is a binomial theorem we can use. MA equal to how much? Kx plus K into delta L minus 2qp by 4 5 epsilon naught and into 1 by L cube and 1 minus 3 into delta L by L. To simplify, MA equal to how much? K into x plus K into delta L minus 2qp by 4 5 epsilon naught into L cube minus into minus plus 6 into q into p into delta L whole divided by 4 5 epsilon naught into L cube into L how much? L power 4. I told you my target, I should not continue any. Only I have to continue kx only. Kx means first equation we found na. What the first equation? Kx, this equation is there na. What that equation? K into x equal to pq divided by 2l cube into pi epsilon naught. Is the time to use that. I mean, from this equation, p into q by L cube into pi epsilon naught equal to how much? 2kx I can substitute. Substitute here and here also. MA equal to kx plus k into delta L minus qp divided by pi epsilon naught into L cube. How much that is? How much? 2k into x and plus 6 into delta L I will write aside and 4 into L I will write aside. The remaining thing is qp will come. So qp this one and pi into epsilon naught and into L cube. This qp into qp by pi epsilon naught into L cube value how much? 2k. Substitute here. So m into a equal to kx plus k into delta L. The two twos are cancelled out. So minus kx plus two twos are two threes are. So how much? 3 into delta L by 2 into L and into this qp by pi epsilon naught into L cube value how much? Totally 2k. 2 to here also gets cancelled out. Kx cancels out. So MA equal to how much? K into delta L minus 3 into delta L by L into Kx.
Sir, plus sir.
Sorry, plus. So if you simplify something, you can take it outside. Delta L, I can take it outside. K into delta L, I can take it outside. So 1 plus 3 into x v into x by L. So here something MA equal to how much? K into delta L plus this is 3x by L into K into delta L. Here this x by L means comparing with to x, it is very, very little only, no? I mean, this x by L you have to remove, and in the place of the x by L, you have to replace with this K into delta L. First equation I can take, no? First equation, this x by L we have to remove. This x by L value, almost all, this x is the very little elongation and initial elongation here. X by L, almost all we can take it as a 1. Why? Because x is very, very small and L value is very, very large enough. You can neglect this value because we have to express in terms of K into delta L only. So I can write MA equal to how much? K into delta L plus 3 into K into delta L. Here you can take x by L equal to almost all 1. I mean the x you can take it as a L very nearby. Initially, very great elongation is there initially. Comparing it to delta L, this x is almost all equal to L. You can take like that. MA equal to how much? 4K into delta L. A value how much? 4K by M into delta L. Similar to A equal to omega square into very little elongation. So here omega square equal to given 4K by M. Square if you send that side under root, and 2 pi by T equal to how much? Under root of 4K by M. T equal to 2 pi under root of M by 4K. I have to see the data. As per the data, frequency is asking. Frequency means what? 1 by F, time period equal to. So F equal to how much? 1 by 2 pi into under root of 4K by M. F value given in the data, F value equal to 1 by delta into under root of K by M. 1 by delta into under root of K by M is given. K by M cancels out. So 1 by 2 pi into root 4 means what? 2. That equal to 1 by delta. 2 cancels out. So delta value 5 is your final answer. 3.14. Very simple, but patience is required. Better to skip this kind of equation in the beginning. Here the question is saying parallel plate capacitor of capacitance C is there and a spacing D between the two plates and area is capital A. So what is the new capacitance C equal to? A into epsilon naught by small d, capacitance formula. Keep aside equation number 1. Now the region between the plates is filled with n number of dielectric layers. Imagine this is one parallel plate capacitor. Like that, how many number of layers are there? Like capital N number of layers are there parallel to the plates, and the thickness also given. Small d by capital N is given, and the dielectric constant of the mth layer. Assume there is the mth layer at some distance x meter and some thickness is dx meter. Its dielectric constant also given. The dielectric constant of the mth layer is k into 1 plus small m by capital N. M is the number of layer. Capital N means total number of layers here. Small d is nothing but total distance between them. Total distance between them is small d, and the last layer is the n number of layers. To take the last layer is there now, that is capital N. Now for a very large n is more than 10 power 3. I mean the number of plates are more than 1000 plates are there. And the total capacitance C is given. So this is not the capacitance then. That is given alpha into K into epsilon naught capital A divided by D into ln of T. So we have to find the alpha value, right? So directly it is not possible. All the plates are in the. I will assume first of all this capacitance I will find. I will take one small element at a distance x meter and thickness is what you said dx meter. I will find the capacitance first. What is the capacitance? Dx equal to A into epsilon naught by uh, distance between them. I mean the thickness only. That is nothing but dx. So dc is nothing but A into epsilon naught by dx. K value is given. For mth layer, K value how much? K into 1 plus small m by capital M. Is it clear? Anyway, dx is in the denominator, so it should not be in the denominator. I will do invertendo. So 1 by dc equal to dx whole divided by A into epsilon naught into k and bracket start 1 plus m by capital M. K we should not touch epsilon naught constant, k constant, but m by n ratio is there. Layer to layer m will vary. So I can write one thing. The ratio of x by d is equal to the ratio of what here? M by n I can write. X is corresponding, I mean the element is corresponding distance is small d. and the last layer, it is a distance nth layer. Mth layer is a distance x meter. The last nth layer is a distance d meter. I mean, distance is proportional to number of layer. What we consider the mth layer distance is x by d proportional to m by n I can write. Means x by d equal to small m by n. In the place of m by n, I can substitute here. So 1 by dc equal to dx whole divided by a epsilon naught into k whole divided by 1 plus m by n value how much? X by d. So 1 by dc equal to dx and whole divided by a epsilon naught into k and d plus x divided by small d. So 1 by dc is equal to d into dx. Be careful, dx is different. And a epsilon naught into k and x plus p. So 1 by dc equal to how much I can write? Small d divided by a epsilon naught into k into dx and whole divided by x plus small d. I want total capacitance, so integrate on either side. Such elements are lying from x equal to 0 to x equal to small d. 1 by integration of 1 into dc I have to write. D by a into epsilon naught into k. What integration of 1 by x plus t? Ln of x plus t. Put the limits from where to where? 0 to small d. So 1 by c equal to d divided by a epsilon naught into k. Bracket start ln of d plus d how much? 2d minus ln of d. So 1 by c equal to how much? d divided by a epsilon naught into k. Ln of a minus ln of b how much? Ln of a by b. 2d by d. dd cancels out. So 1 by c equal to how much? d into ln of 2 divided by a epsilon naught into k. So capacitance C equal to a epsilon naught into k divided by d into ln of 2. As per the data, question is given capacitance how much? Alpha into k into epsilon naught into a divided by d into ln of 2. A epsilon naught k, d ln of 2, d ln of 2 cancels for alpha value 1 is your answer.